In this video we are going to describe about the projectile motion. Now what is a projectile? Examples of projectile are suppose javelin throw, javelin, discus, we kick a football. So when the particle is made to move upwards with a velocity of suppose u with an angle theta with respect to the horizontal, the particle moves in this fashion. Now this is a two-dimensional motion. This is a 2D motion. Why this is a 2D motion? Because the particle moves along the x-axis as well as the particle moves along the y-axis. So this is a two-dimensional motion. Now we are going to break this u into two components, u cos theta and u sin theta. Now why did we break this into two components? To discuss the motion of the projectile in the x direction as well as along the y direction separately. Now this is the motion along the x direction. This is known as the range of the projectile. This is known as the range of the projectile. Now this range is the value we get for the displacement of the projectile in the horizontal direction or x direction is equal to u cos theta into the time of flight, the time required for the projectile to move from this point to this point. Now this is the maximum height attained by the projectile. Now the height attained by the projectile is because of this velocity. The particle moves along this direction in the x direction because of u cos theta, and the particle rises from the ground level to the topmost point according to this velocity. Now the most important thing is the projectile motion is under the effect of the gravity or g. Now because of this g, the projectile moves upwards and then it comes down to the earth. Now the value of g or the effect of g, or rather the effect of g is along the y direction, and the motion along x-axis is independent of g, because g acts downwards. It doesn't act in the horizontal direction. Therefore this velocity u cos theta is not acted upon by any gravitational force. So this velocity we can take it as a uniform velocity. The product of the value of velocity and the angle, the cosine of the angle, the product of u and cos theta remains constant throughout this motion along the x direction, whereas u sin theta gets affected by the value of g when it moves upwards till it reaches the point here. So I repeat, effect of g is along the y-axis and the motion along the x-axis is independent of g. Now we try to find out the formulas of the maximum height, the range, the time of flight, etc. First we can find out the maximum height. Now maximum height we have denoted it as h. Now according to the formula, v square is equal to u square minus 2gh. We can replace v as 0, u as u sin theta 2g and h by capital H. Now what is the logic behind this? Now as the particle moves upwards with the initial velocity of u sin theta, when the particle moves or reaches the point, suppose this point is A, the peak point A, the velocity of the particle or the vertical velocity, vertical component of velocity at point A becomes 0. At point A, there is only one velocity, that is the horizontal velocity, because the particle is also moving in the x direction. So when the particle moves from point C to point A, at point A there is existence of only the horizontal velocity, and the vertical velocity becomes 0. So we have replaced the final velocity as 0, initial velocity u sin theta, and minus 2gh. So h is equal to u square sine square theta by 2g. So we have derived the formula for the maximum height. Now we try to find out the time of flight, denoted as t. Now the particle, when it moves from point C to A, suppose the time taken is t1. So we can write from the formula v is equal to u minus gt. Replace v as 0, u as u sin theta minus g t1. So t1 is the time of ascend, the particle to ascend to the point B, to point A, time of ascent to point A or the peak point. Now t1 is equal to u sin theta by g. Now we all know the time of ascent is equal to the time of descent. So t can be written as 2t1 as time of ascent equal to time of descent. So t comes out to be 2u sin theta by g. So this is the formula for the total time of flight. Alternatively, we can also use this formula s is equal to ut minus half gt square in trying to find out the time of flight of the projectile. Now as a particle moves up from this point to point A and it gets back to point C, so the displacement of the particle is 0. Replace t equal to t, so t becomes 2u sin theta by g. Now we are trying to find out the value of the range of the projectile. Range of projectile means the maximum displacement along the y direction. Now as I have said earlier, the displacement along the x direction is independent of the gravity force. So r is equal to u cos theta into t, the time of flight. According to the formula, s is equal to vt. As there is no acceleration, we can use s is equal to vt. So u cos theta and t we can replace as 2u sin theta by g, as we have derived in point number 2. So this can be written as u square 2 sin theta cos theta by g. So u square sin 2 theta by g. So the value of r is u square sin 2 theta by g. Now the value of theta for maximum range for a particular velocity of projection. Now the value of velocity of projection is taken to be constant. Value of g we know as constant. So r becomes maximum where? R becomes maximum when the value of sine 2 theta becomes maximum, that is 1. This is the maximum value. So 2 theta is equal to sine 2 theta is equal to sine 1 means 90 degree. So 2 theta means 90, theta is equal to 45 degree. So for any velocity of projection, the maximum range that can be attained by that projectile is when we throw at an angular projection of 45 degrees. So the value of the maximum range becomes u square by g. This is the value of the maximum range. Now an important thing, that is, if you fire a projectile with a velocity of u at an angle theta and another projectile with the same velocity u but the angle of projection is 90 minus theta. That means the angles are complementary to each other. Now suppose one is thrown at an angle of 30 degrees, so the other projectile angle of 60 degrees. If we take the range of the first projectile to be r and the second projectile to be r dash, we can derive that r dash is equal to r. That means for the complementary angles, the ranges of the two projectile becomes the same, becomes equal. How do you derive it? We write r as u square sine 2 theta by g and r dash is u square sine 2 into 90 minus theta. We all know that sine of 180 minus 2 theta becomes sine 2 theta by g. So u square sine 2 theta by g, that means is equal to the same value as r, so r dash becomes equal to r. So for complementary angles, the ranges of the projectiles are the same. Now we try to derive a locus equation of the trajectory of the projectile. Now suppose this is the x-axis, this is the y-axis, the projectile trajectory is shown here. We denote any arbitrary point as p. The coordinates of the points is x and y. That means the shift along the x-axis is x, along the y-axis is y. Now finding out the locus equation means the relation between x and y. Now how to find out? We have to find out in the similar procedure as x is equal to u cos theta into t. Now t is arbitrary time. This is the equation of the trajectory along the x-axis. Now the equation along the y-axis, y is equal to u sine theta into t minus half gt square. This is along the y-axis. Now the variable that has to be eliminated between these two is t. So we replace t from equation number 1 into the equation number 2. T is equal to x is equal to u cos theta. So y is equal to u sine theta x by u cos theta minus half gt square x square by u square cos square theta. So y becomes, u gets cancelled, so x tan theta minus half gx square u square cos square theta. Now this represents the equation of a parabola. Now the general equation of parabola, y is equal to ax plus bx square. Comparing this with this equation, now y, ax, the a is a constant term, that is tan theta, and x square term is here. So this half u square, half g into u square by cos square theta, half g by u square cos square theta becomes b. So this is the equation of a parabola. Now lastly, one more point. When we have thrown the projectile with the velocity u at an angle of theta, the projectile moves upwards. Now at this point, suppose the point is this is O, this is A. Now at point A, the velocity decreases, because as we move upwards, the velocity decreases and we take the value to be at u dash. The angle also changes from theta to phi, but the horizontal velocity along this direction, horizontal velocity becomes u dash cos phi, and along this direction is u cos theta. As I have said that the horizontal velocity component will never change, so u cos theta is equal to u dash cos alpha. When we reach the peak point, here the phi becomes equal to 0 degree, so the component along the y direction, x direction becomes v cos of 0 degree. Suppose the velocity here is v, so v cos of 0 degree means the value comes out to be v only. So u cos theta is equal to v here.